Alright guys, this is lesson 7.2 and this is the first video. And it's more law of signs, and after the first section you might think, well, I kind of know the law of signs. I know how to do this. But you're going to see here, sometimes it's not quite so simple. And that's why this section has this great title. It's called the ambiguous case of the law of signs. And what will happen is, or what happened in the first section was, you had two angles and a side, and then you immediately found the third angle, you found the two sides, and it all worked out very nicely. Okay? So we were given two angles, we were given one side, and it all worked out very nicely. But the law of sines will also work if I gave you two sides and one angle. So instead of two angles, one side, two sides, one angle, it will still work. And this will work for things like side angle. It won't work so well for side angle side because you'd have three different letters in the law of sines to work. You really want two letters that are the same. It won't be work in the case of the side angle. So I have a triangle. Here's side A and side B and side C. So here's angle C and angle B and angle A. So in the case of a side angle, that would look something like, oh, I don't know, side, and skip the angle, side, and then we come to the angle. So look, we have two letters the same. We can use the law of sines. So it will work. The law of sines will work. The catch is side angle was never a geometry proof. It was never a geometry proof because if I give you a side and an angle, there can be some cases more than one triangle you can draw with that information. So we'd have to be careful of this. This can be ambiguous. And we'll do three examples. There's a couple other examples in your notes, but three examples to make this case, and we'll see if we get to the other two examples or not. They may not be necessary. Okay, so law of sines, you can write it. There's two versions of it. Either way is okay. When you're finding the side, you might want the version with the sides on top. So this version right here. And when you're finding an angle, you might want the version with the angles on top. But either way, this is a law of sines. Okay, let's look at our first problem and see what we've got here. So solve the triangle. And look, they gave you angle C, they gave you side C, they gave you side A. We need to find angle B, we need to find angle A, and angle A. We need to find side B. Okay, how do you start this problem? Well, we have both parts of C. We have one part of A, so let's get angle A. So I'm going to write this down. I'm going to write sine of A over A equals the sine of 82.2 over 7.62. So this looks like a correct setup for the law of sines. Since I'm looking for an angle, I'll put the angles on top. How do I solve this? I cross multiply. So 7.62 times the sine of A equals 10.9. Sine of 82.2, very routine. Get sine of A by itself, and I get 10.9. I've got the sine of 82.2. I'll divide it by 7.62. All right, let's pull out the calculator and let's figure out what this is. All right, let me scoot that over just a little bit so we can see it. So we have 10.9. I've got the sine of 82.2. Close that, and let's divide it by 7.62. And I get this answer. And let me just write that down. I'll come right back to this. So equals, it was 1.4 something. 1.42? We'll put that in a second. But guys, that's the sine of A. I need angle A. When you're looking for an angle, we hit the inverse button. So what I want to do to find A, to get angle A, I'm going to take the sine inverse. I believe it was 1.42 or something like that. Let's pull that back up and see. So I'll take the sine inverse. And some of you guys know exactly what's going to happen, but let's just show you in case you don't know what's going to happen. Let's take the sine inverse because I need an angle. When I'm looking for an angle, that's the inverse trig function. I'll take the sine inverse of 1.42, and I get an error. And you probably weren't surprised by that. Maybe you were. Shouldn't have been. I get an error because, look, I'm taking the sine inverse of a value bigger than 1. Sines don't get bigger than 1. It goes between -1 and 1. You can't take the sine inverse of a number bigger than 1. That leads to an error. So what does that mean? We were using the law of sines perfectly. What does that mean? It means you cannot go home and draw a triangle with these dimensions. This is an impossible triangle. So, and again, the situation they gave us was a side, and an angle. I think that was down a geometry proof of congruence, and it just doesn't work. And go home and try it. But one clue you might have is look at side C, a 7.62. Look how big angle C is, but side A is quite a bit bigger than side C. So angle A would have to be quite a bit bigger. We've already used up 82 degrees, and there's just not enough degrees left out of the 180 in a triangle that we could actually make a triangle out of this. If you don't believe me, go home and try to make this triangle. It'll be extra credit if you can do this, if you can make this triangle. So this is our first case of applying the law of sines, and it leads to an impossible triangle, so you can call that just no such triangle. All right, there's 2 more cases to show you. I think we'll just go video by video. This was the nicest answer out of the 3. And the next 2 get a little more complicated, but let's just call it for this first one. We'll call it here in this first video.